In this slidecast, we'll talk about tree traversals. So often we want to determine the nodes of a tree and their relationship, and we can do this by walking through the tree in a prescribed order, and we visit nodes as we encounter them. And we call this tree traversal. There are three kinds: in order, pre-order, and post-order. Now the pre-order traversal is that we visit a root node, then we traverse the left subtree, and then traverse the right subtree. For in order, we traverse the left subtree, visit the root node, then traverse the right subtree. And post order, we traverse the left subtree, traverse the right subtree, and then visit the root node. And here are the algorithms listed for each of these traversals. For example, pre-order is if the tree is empty, we return. Otherwise, we visit the root, we do a pre-order traversal of the left subtree and then the right subtree. So these are recursive algorithms, and the others are the same. So you'll notice in each of these algorithms, we always traverse the left subtree before the right subtree, and the difference is when we visit the root node, either at the beginning in pre-order, between the traversals for in order, and after the traversals for post-order. Now we can visualize these tree traversal by imagining a mouse that walks along the edge of a tree. And if the mouse always keeps the tree to the left, it will trace a route that's known as the Euler tour. And the Euler tour is a path traced in blue in the figure on the right. So here's this blue path as the mouse traverses the tree, always keeping the tree to the left. All right, so that's the blue route, the Euler route, or the Euler tour through a tree. Now, an Euler tour is a pre-order traversal. And the sequence in this example is A, B, D, G, E, H, C, F, I, and J. And the mouse visits each node before traversing its subtrees, as shown by these downward arrows. So as we go along the blue path, every time we encounter one of these downward arrows, that's visiting the node in the pre-order as a pre-order traversal. Now, if we record a node as the mouse returns from traversing its left subtree, and these are shown by the horizontal black arrows in the figure, then we get an in-order traversal. For instance, as the mouse goes along this path, at this point there is no left subtree of D, so D will be the first node visited in the in-order traversal. Then at this point we'll do G. Finally, when we come up to this point, we've traversed the left subtree of B, so B will be our third one. And you can continue on your own and go through and see if you can demonstrate, kind of show yourself that this is a correct in-order traversal of this tree following this description. So pause the slidecast and do that on your own. And finally, if we record each node as the mouse last encounters it, we get the post-order traversal. And this is shown by the upward pointing arrow at each node. So the last time we're going to go by a node, right at this point is our last time we'll be near G, so G will be the first one in the sequence, then followed by D, then followed by H, E, and then finally B at this point. So this corresponds to the post-order traversal. Now, an in-order traversal of a binary search tree results in the nodes being visited in sequence by increasing data value. So here is a tree that's a binary search tree because the tree is ordered, and if we do an in-order traversal, then we'll first encounter K9. Remember, in order is when once we've evaluated the left subtree, then we visit the node. So we'll see K9, then we'll see cat, finally dog after we visited this subtree, and then we'll get to have wolf. An in-order traversal of an expression tree results in the sequence, this sequence, and this is in infix notation. So if we insert parentheses where they belong, we get this infix form of the expression. And it assumes we started with this expression tree. Now, a post-order traversal of an expression tree results in the following sequence, and this is the postfix or reverse Polish form of the expression, where operators follow operands. And a pre-order traversal of the expression tree gives this following form, and this is the equation in prefix form, where the operators precede the operands. So for our expression trees, these three different traversal patterns give us the different kinds of expressions in terms of prefix, in order, or postfix form. And that's the end of this slidecast.